All right, so for your virtual day today, a reminder that you should be in the weekly schedule, which is where you should have gotten this link. So we're going to go over the answers to what you did yesterday and then get a little bit of a head start on worksheet 23, which is what today's work is. So on 22, take a look. Let's check and correct. So in your factor corner, we have our factor lists for 22 and negative 22. Then for our polynomial, remember it's always factors of the constant. So in this case, factors of 22 that add to the middle coefficient, which in this case is 13. So I circled the winning numbers. 2 and 11 are the factors of 22 that add to 13. So that means 2 and 11, both positive, are what go inside the parentheses. So then when I solve by setting each equal to 0, I get x equals negative 2 and x equals negative 11. For my chart and my graph, very similar to what we had the past few days. So we're given a function. All I'm doing is plugging each of these x values in place of x in my function and simplifying. So negative 2 times the value plus 2. So negative 2 times 0 plus 2 is 2. Negative 2 times 1, which is negative 2, plus 2 gives me 0. So on and so forth. So you can see my work for each of these out on the left side, as well as the values that I am getting. So we should have seen a pattern in there. That pattern is that I am subtracting 2 each time, which is why my first difference should be negative 2, because I'm decreasing, hence the negative, and what I'm decreasing by is 2 each time. My second difference is anything minus itself is always 0. In my ratio column, here's another opportunity for us to talk about this, the difference between having 0 in the numerator and having 0 in the denominator. So 0 in the numerator is okay. 0 divided by any non-zero number is just 0. 0 divided by 10 million, still 0. But 0 in the denominator of a fraction is not allowed. That makes our function undefined. If you try to do that in your calculator, it's going to tell you either undefined or error or non-real answer or some sort of error message. On my plotting, remember I'm just x-coordinate, y-coordinate. X-coordinate is how far I'm moving left or right. Y-coordinate is how far I'm moving up or down. So 0, 2, right here. Here's 1, 0. Here's 2, negative 2, 3, negative 4, and 4, negative 6. This graph is linear. The points are making a line, and it is decreasing because the y values are getting smaller as we go to the right. 1 through 4, exact same thing that we went over on worksheet 21. So again, it's really important that you understand the notation. What this means is to go to the function named f, which is this one. This one's named g, this one's named h. So go to the function named f and replace the x with a 2. So that's exactly what I did. I replaced the x with a 2, and then I used PEMDAS to simplify. So multiplication first, and then the addition. So all of these, I went to the appropriate named function, and I plugged in the value that's inside the parentheses. So g of negative 1, I went to the g function. I plugged negative 1 in place of x, and I simplified. Remember, PEMDAS exponents come before multiplication. So negative 1 to the second power is positive 1, then 3 times 1. And then you can see my answers and my work for each of those. Make sure that you have everything about these definitions that we wrote down in class corrected. Remember that we had this typo that we corrected, so make sure you did that on your worksheet as well. So remember, absolute max and min are the very highest and very lowest points on the graph if they exist. Remember, if there's an arrow pointing that direction, that means it doesn't exist. We write none. Relative max, relative min cannot be on a horizontal and cannot occur at the endpoints of a graph. So, checking the ones that you did on your own, because this is what we did together. So you can, pause the video to double check if you think you didn't write something down correctly for most of what we did together. I think almost everyone finished all of these except maybe that last X and Y intercepts. Remember that on these ones, the intercepts that didn't cross at an exact point, we guesstimated this time. What you see on the test or assessment is going to be somewhere where you can tell exactly where it is, like, this guy, for instance. But there were 5 x-intercepts here. 1, 2, 3, 4, 5 times it crosses the x-axis. Only 1 on the y-intercept. All right, so those are the ones we did together. Here are the ones you needed to do on your own. So relative minimums are the bottom of valleys. So in number 7, I had 2 of them. Here's the bottom of a valley. Here's another bottom of the valley. These are the coordinates that you need to have listed. Which one you listed first doesn't matter. There's no order, but make sure you have both. Relative max is the top of a hill. This is the only one. These are endpoints. You cannot have a relative max or min at an endpoint. So only 0, 3 for that. Absolute min means very lowest point on the graph. The very lowest is right here, 1, -1. Absolute max, very highest point. Don't say this guy. This guy is up higher. It's an endpoint, but that's okay because this is absolute. No endpoints on relative max and min. Absolute, you can certainly use the endpoints. So -4, 4 on that one. Remember, domain and range, when our graph is connected, should be written with inequalities. So domain, because that's my x variable or my inputs, I look left to get the left side boundary. I look right to get the right side boundary. Remember, the variable is x, so I'm looking at the x values only. I don't care about the y values when I'm looking at domain. So as I look to the left, the furthest left I can go on the graph is right here. The x coordinate at that point is -4. So that's where this came from. It has an equals because that's a closed circle. As I move to the right of the graph, the rightmost point is this one right here. That x coordinate is 3. So my domain is x is between -4 and 3. My range are the y values. So to get the lower bound, I look down. To get the upper bound, I look up. So as I'm looking down, the very lowest point that I can reach is right here. The y, range is y, the y value there is -1. As I look up, the very highest point I can reach on the graph is this one. The y value there is 4. Y-intercept is located at that local max at 0, 3. On number 8, relative mins. There is the bottom of a valley here, bottom of a valley here. Those are the 2 points that I have listed. So 3, oops, and I messed that up. -3, -2 is the ordered pair that goes here. then this guy is at 2, -6. Relative max values, tops of hills. Here's the top of a hill. Here's the top of the hill. So -1, 2 is this one. This relative max is at 4, 5. There is no absolute min because this has an arrow on it. I know that that arrow is drawn higher than this point. That doesn't matter. There's an arrow. That means that this graph continues in this pattern, which is down and to the right. So there is no absolute min. There's an arrow pointing down. Likewise, there's no absolute max because there's an arrow here. That value is going to continue in this direction, which goes up. So there is no absolute max, so no absolute extrema at all on this graph. Also, because of those arrows, when I go to do my domain, much like on the one we did together in number 6, when I look to the left, this arrow is continuing left. So there is no like wall that I hit of leftmost value. So it can continue -infinity. On the right side, same thing. As I go to the right, this arrow is going to keep going to the right. So there is no bound on how far right I can go. So that gets a positive infinity. So -infinity to positive infinity is the domain, which is really saying that x can be any real number. For the range, again, this one's a little tricky because you have to notice the arrows. Yes, this looks like the lowest point on the graph, but the arrow indicates otherwise. The arrow is telling me this keeps going down. There is no lowest point, so -infinity there. Same thing with the upper bound. This looks like the highest point on the graph, but you'd be ignoring that this arrow is traveling up. Eventually, this side over here is going to be taller than this point. So no bound on the upper limit either. So my range is also -infinity to infinity. We just have a y in the middle instead of an x. Okay. Hopefully that helps you get that corrected, clears up questions that you may have had on that. If you have additional questions, of course, you can email me or ask me in person when you see me. So now we're going to go on to 23, which I purposefully set up mostly to be review so that you wouldn't need a lot from me instruction-wise. Everything you see up here is what we've done many, many times before. So factor corner and coming up with our chart, graph, and what we notice. None of that is new. That's all for you to do. What we do have that's a little bit new is what's in this section, starting with number 1. This is function notation, which we should be used to seeing. We just went over it on worksheet 22, and it was on the previous one as well. But we've not done it from a graph. Actually, from a graph is much easier because you don't have to do the algebra or the PEMDAS. Remember that what this is saying is that the x value is -2. So all you have to do is go to the graph, find the y value where x is -2. So I go to where x is -2 on the graph, -1, -2, and then I find the point, which is right here. This point right here is the point -2, 1, 2, 3, 4. So f of -2 is 4. And that's all we write. So this is asking you, find y when x is -1. Find y when x is +1. So all you're going to do is find these x values on the graph and then write down the y value that's associated with it. And that's all. Number 4, what is the x value when f of x equals 0? So if you go back to when we first learned function notation, one of the things that it said was that f of x is equivalent to y. So remember that this right here is the same as saying y equals 0. So what is the x value when y equals 0? So I look on the graph to where y is 0, which is right here. When y is 0, in this case, the x value is also 0. So that would be our answer. Again, no algebra to show. There's just identifying from the graph. Number 5, what are the possible x values when f of x equals 4? Again, this is the same as saying y equals 4. So I go on the graph, 1, 2, 3, 4. Y is 4 in 2 different spots here, this point, as well as this one. So possible x values are not only -2 that I've listed over here, but over here, the x value there is +2. So -2 and +2 are the possible x values when f of x is 4. Domain, range, relative min, relative max, absolute min, absolute max. That is all review. So please, please, please make sure you're practicing. Again, it can make sense when I say it, but if you never do it yourself, you're going to be woefully unprepared for the assessment. Please make sure that you're doing your practice with fidelity. 12 is pulling from earlier in the unit. It says, is f of x a function? Explain your reasoning. So you are deciding, does this graph pass the vertical line test or not? And you're explaining. On the back, more review. So I gave you 3 different graphs. You are asked for the domain, for the range, for all the relative and absolute extrema. So the exact same things that we learned about yesterday. Please be careful because all of these graphs have arrows somewhere, which is obviously going to affect either your domain or your range or both. So make sure you pay attention to those. 16 is making sure that you understand what all of these things mean. So this time it asks you to graph a function. So it has to be a function. Make sure your final graph passes the vertical line test. If it's a function, it has to. So you are going to draw a function that has a y-intercept at 0, 2, that has this domain, this range, and has 2 total relative maximums, 1 relative minimum. So all of these 4 requirements need to be met on your graph. Yours might not end up looking the same as mine or someone else's. As long as I can put a check mark next to all of these things, then yours is fine. This is really applying the concept, content, knowledge. All right, last ones. Use the function g of x equals 200 minus 35x to answer the following questions. What is g of 2? So again, when it's worded like this, g of 2, this means plug in 2 for x because the 2 is inside the parentheses, just like x was inside the parentheses. So g of 2 is 200 minus 35, and then instead of x, I'm putting in 2 because again, this is showing 2 is in place of the x. So in place of the x, I put 2. And now I'm going to simplify. So multiplication first, 35 times 2 is 70. So I've got 200 minus 70, which gives me 130. So g of 2 is 130. Notice this in contrast to the way this is asked in 18. What is x if g of x is 60? This is not telling you to plug in 60 for x. This is saying g of x is 60 or y is 60. The 60 goes in here. So 60 equals 200 minus 35x. Again, that's why it says what is x. This is requiring us to solve the equation. So I told you that solving equations would never go away. In every unit, we're going to have to be able to solve equations. So in this case, if I want to get x alone, I first need to subtract 200 on both sides. So 60 minus 200 is negative 140 equals, make sure you bring down the negative, negative 35x. So x is almost alone. I just now have to get rid of the negative 35. Right now, the negative 35 is multiplied times the x. So I undo multiplication by division. So again, you have to make sure that you simplify. Negative divided by a negative is going to give us a positive. 140 divided by 35 gives me 4, so 4 equals x, or x equals 4, however you want to write it, is our answer. So what is x? If g of x is 60, x would have to be 4. And you can always double check it by plugging it back in. Okay, so everything else, again, what I left you is review. The new stuff we did some examples on. So finish worksheet 23. Remember that I will stamp both 22 and 23 for you tomorrow. Have a good rest of your day.